Imagine a world where hundreds of tiny robots join forces, swarming through rubble and ruins to save lives. On Fact Channels, we're about to uncover how robot teamwork is flipping the script on search and rescue missions, making heroes out of machines that move as one mind. From disaster zones to technological breakthroughs, let's see what happens when unity really means survival. In the shadowy wreckage left behind by disaster, hope can arrive on dozens, sometimes hundreds, of tiny mechanical legs. As sirens fade and the dust settles, a new swarm intelligence scurries, flies, and crawls into places human rescuers cannot reach. Few realize the roots of this robotic revolution began not in tech labs, but in nature's own blueprints. Researchers in the late 20th century became transfixed by the collective problem-solving of ants and bees. They wondered, could machines learn to search and act as one, even when cut off from command? Consider the disaster zone after a magnitude 7 earthquake. Crumbling concrete, gaping crevices, and toxic gases bar entry to all but the brave, or the expendable. Enter robot swarms, resilient teams of micro-machines mapping unknown dangers in real time, their collective intelligence allowing instantaneous decisions without waiting for orders. What shocks many is the scale. Swarms often number in the hundreds because redundancy isn't just a backup, it's a necessity. Each robot is expendable, together they're unstoppable. If 20% succumb to falling rubble, 70% more adapt their patterns within seconds, learning from each loss. Imagine metallic centipedes slipping through collapsed pipes, quadcopters weaving airborne webs above smoldering roofs, and palm-sized rovers scrambling over hazardous debris, all in synchrony. Their secret? Complex algorithms inspired not just by insects but also by chemical reactions and even bird-flocking physics. The interface between biological inspiration and code is where science fiction becomes science fact. Swarms borrow ant pheromone logic by tagging safe zones with digital markers, signaling comrades where radiation or fire blocks the path, and where survivors might still be found. One pivotal breakthrough came with stigmergy, communication through environmental changes rather than direct signals. A robot dropping a heat sensor or marking a wall with UV paint can spark entirely new behaviors from following bots. No words exchanged, just action reacting to action. Ironically, individual swarm members are shockingly simple. Low-cost sensors, basic wheels or rotors, minimal onboard computing. It's the collective behavior, emergent intelligence, that makes them formidable, far outstripping any single bot's capacity or cleverness. From Chernobyl to Syrian earthquake relief, these miracle machines have already saved lives no human knew were at risk, quietly mapping radioactive ruins or relaying the faint heartbeat picked up below 10 meters of rubble. But as astounding as current achievements are, today's swarms only hint at tomorrow's possibilities. Imagine shape-shifting robots forming bridges across chasms or congealing into temporary scaffolds for trapped survivors. A feat some researchers say is less than a decade away. Hidden within these technological marvels is a paradox that few ponder. Increased autonomy means decision-making happens on the fly, with no time to ask permission. Sometimes robots choose routes never programmed into them. Sometimes they risk themselves unexpectedly for the greater mission. Unexpectedly, the data generated by these robotic scouts has revolutionized more than rescue logistics. It has transformed our understanding of how disasters unfold in real time. Forensic swarms now reconstruct building collapses second by second, helping engineers understand exactly what went wrong and how to prevent it next time. Yet ethical dilemmas lurk beneath each innovation. How do we ensure swarms don't make reckless choices in uncertain environments? What if their emergent behaviors stray beyond their programming? And is that always a danger? Perhaps most astonishing of all, swarms aren't limited to land or air. Experiments are underway with aquatic swarms swimming beneath tsunami debris fields and nanobot collectives traversing contaminated groundwater, scanning for traces of life at a microscopic scale. Thanks for watching Fact Channels. Be sure to like and subscribe for more amazing facts.